Hi, welcome to Fonet Pi videos. This is DC here. In this video I'm going to show you how to use EEPROM memory in OMNIKEY reader writer. So not all reader writers from OMNIKEY have the EEPROM memory. So I'll be using the 5022 and 5422 series. So the size of the EEPROM memory might vary. I've not seen, because I have got only two readers, I've not seen any difference in the memory size. Now these two readers have got 1024 bytes of EEPROM. So the data you keep in the EEPROM is not secure. That means there is no password protection and you can always read and write. So if you are a developer, you can make the data you write very secure by using some kind of a cryptography functions to encrypt and decrypt the data, and you can use any sort of key to encrypt. Some of the ways you can do is you can use the serial number. Supposing this is the data you want to store in the EEPROM, I can use the serial number of the device, or you can use the custom reference number, or you can use installation number. There are so many ways you can try to encrypt and decrypt the data. So eventually assume that you're going to write 1024 bytes of data. This data could be the customer information, or this could be the installation data, or it can be anything you want to put in this reader writer. So you can use the AES encryption, or you can use the 3DES. So you can use any kind of custom encryption and decryption algorithm, and the encrypted data what you get here, you can store it in the EEPROM. So what I'll be showing in this video is you're going to see the vendor specific commands that are reserved to read and write to EEPROM. You're going to understand the command structure. You're also going to understand the structure of the response you get from the reader, and I'll be using HID 5022 and 5422 reader writers. As you can see here, I've got two readers connected to my laptop. I've got the HID 5022, the blue one, and HID 5422. I do have HID 5431, but that doesn't have the EEPROM. So you cannot use this or learn EEPROM commands using 5431 or 5421, sorry. Now because we are trying to use the EEPROM which is in the reader, you don't have to place any RFID tag. You don't need a RFID tag to learn the EEPROM commands. So in fact you don't have to choose reader writer here. Now if you already have this this learning software, this is available in version 1.9. so on the right side there's a small thing menu. In my previous video you have seen how to use the APDU console. So here if you choose EEPROM, so I'm going to choose the reader writer. So even though I've got two reader writers here, I've connected only the 5422 because I don't have enough USB ports. You'll come across this problem, so you might have to buy a USB extension if you want to connect more readers. So here it doesn't matter which interface you select. So I'm going to choose the first one and click on connect to reader. I'm going to come back to these commands at the later part of the video. First I'm going to show you what you can do with this EEPROM memory. Now as soon as you connect here, the software says it has got 1024 bytes of EEPROM, and if I click this read entire memory, you can see that all these 1024 bytes is read and it is shown here, and I've already keyed in, already saved some lorem ipsum random data here, so you can see some data here. You can use the hex and the ASCII and hex button to switch between the hex and the ASCII code, and I can also fill this entire 1024 bytes with the random, with any data you want. So most often, if you have not used the EEPROM data, the entire EEPROM 1024 bytes will be set to FFs. So I'm going to write the entire EEPROM memory. If you hit that, there's a warning here. You can see now that during the write operation there is a flashing a blue light here. Now it might take some time because you're writing to a EEPROM. Now you can see the message write entire. So the write is successful. So we have just transferred 1024 bytes from this software to the EEPROM. Now if we want to read, to make sure that the write was successful, if you hit, you can see that. Okay, so here what the software has done is it has organized 1024 bytes of EEPROM into 16 bytes row. You can see on the left side you got the byte addresses starting from 0. You got 16 bytes here. The B0, B1, this tells you the offset. This is the 0th address, and the second row starts with byte address 16. You can also use this R and W button to write, so read and write 16 bytes at a time. So I'm going to change this to, so I'm going to change this, and the last byte I'm going to write now, and you can try to read, so you can make sure the write was successful. So using this R and W, you can transfer just 16 bytes at a time, or you can click this editor. So what you see here is the ASCII equivalent of all these 1024 bytes. If you want to key in some information like a customer name or something, any data up to 1024 bytes, you can key in here. So I'm going to just grab a few bytes of lorem ipsum. So go to lorem ipsum and generate. So I would like to generate, say, 500 bytes of data. So you can copy this 500 bytes. You can write 1024 bytes itself. Now because I have got less number of bytes here compared to the memory size, so you can decide how we want to fill the remaining bytes. So I've got only 500 bytes, but we have got 1024 bytes here. I can either auto populate with the zeros, or you can populate with a space here. I'm going to stick with the zeros and save. Now what has happened here is the grid is populated with 500 bytes of data. You can look at here. This is the lorem ipsum data, and all the remaining bytes are populated with zeros. Now I can hit this write this entire memory, and so this will transfer all these 1024 bytes from the software to the reader data. And I think that's all. You can clear this. That's all you got to know about how to read and write to the EEPROM. So next I'm going to show you all the various commands that are used to read and write. If you're a casual user, you don't have to understand these commands, but if you're a software developer or a student or an instructor, then what you're going to see now will be of useful. Now I have just swapped my reader writer here, and this time I'm using 5022 just to show you that even 5022 have the EEPROM. So refresh readers. If you say connect to reader, it again says 1022. If you look at the things what's going on here, so all these standard the WinSCAR DLL command you can see here. You can first see the established context. You can see command to get all the readers that are connected to the device. Then I'm connecting to that device. So this is different from connecting the card. So you'll be using what is called as a direct connect. After that, so because you're communicating with the reader, you have to use the control commands, and the control code for this reader is 3500, which is explained in the software guide of this 5022 reader writer. Now if you look at here, now I'm sending a command to read the EEPROM size. Now in the last video I've showed you how to I have a separate video speaking about the vendor specific commands. This is one of the command, and again here the first 5 bytes, the first 4 bytes, these are the headers. This tells it's a vendor specific command, followed by there are 8 bytes here, and these bytes are organized in the TLV. So again in the last video I discussed about the TLV. It's the tag, length, and the value. So the tag here is A2. So A2 means this command refers to the reader writer API, and this is A2, and this TLV has got 6 bytes, and the value here is again one more TLV. So this is again one more TLV with the tag as A0 and with the length as 04. So A0 again documentation says it is something to do with the EEPROM, and after that you got again one more A0. Again this it's again a TLV. You got A0 and you're passing 2 bytes. This time I'm passing the 94 and 00. So this is the command for getting the EEPROM. So this structure is very well explained in the documentation. I will advise you to go through documentation a couple of times so you get hang of that. Now the response for this command is again a TLV structure response. If you forget about the last 2 bytes 9000, and the first byte BD indicates it's a success, it's a primitive, or it's something to do with there are 2 types of responses. One is a structured and one is a primitive. The BD is a successful response, and this has got 04 bytes, and these are the 4 bytes here. So 94. Again this 94 is a structure. 94020400 is again structured as a TLV where the tag is 94, the length is 02, and 0400, that's more interesting thing here. That's more important actually for this command. So 0400 is the size of the EEPROM. So this is the higher byte and this is the lower byte. This is hex. When you convert this to decimal, you end up getting 1024 bytes of EEPROM. So that's what you have to know about getting the EEPROM size. The next I'm going to hit the read memory. So you can read a byte at a time, or you can read a collection of bytes at a time. Okay, so what I've done here is I've gone through this the various sizes. Now the maximum you can read is 242. It's something to do with the 256 bytes of the response. But since I want to make this number divisible by 16, so I've used 240. That will give me 15 blocks of 16 bytes each. Now if you look at the structure here again, so here this is the vendor specific command to read EEPROM. So if you match this to the TLV structure, you'll come to know that so A2 is something to do with the reader specific, then A0 is the EEPROM specific, then A7 could be now reading the command. And here in this structure you have to send the offset and you have to send the length of the data. So the offset here is it goes here in this TLV, and the length of the data I want to read is F0. So F0 is 240. So you have to see the documentation about this 81. The 81 tag refers to offset, sending offset, and 82 tag refers to sending the length of the data you want to read. So there is an example in the developer's guide about how to read the EEPROM. So what you got here is the 240 bytes of data. If you ignore the last 2 bytes, this is the 9000 success, the SW and SW2, and remaining here the entire thing is again structured as a TLV. So except this D9. D9 says it's a positive response. This is followed by a kind of a TLV. So here this is the 82 is the size. I think it's the same tag used. 82 refers to the size here, and see 82 refers to the size. But here only thing I didn't understand here is 82 is followed by 00. Again, I know F0 is the size. F0 refers to 240 bytes. So you just have to check with the the manufacturer technical support. So here, if you look at here, if you think these 3 bytes is a TLV, 82 refers to the tag, 01 refers to the length of the value, and F0 is the value. Whereas here, 82 refers to the length. If you think this as a whole thing as a TLV, then 82 refers to the length. Probably it could be these 2 bytes refers to the length. Just a bit confused here. Okay, so you are able to read 240 bytes at a time. You can go up to 242, 240, 240. If you go beyond 242, you will get a response that's 9E, which is an error response. So the software is sending the 240 bytes reading 4 times, and the remaining 64 bytes, which is the last chunk of data. If you look at the response you got here, now here you got 9D as a response, followed by the 40 is the length of the data, and this is the 64 bytes. So reading is pretty straightforward now. If you go and hit R here, it's the same read command, but this time the length of the data you want to read is set to 1016 bytes, and see the response code here, 9D is a positive response, and the size of the response is 16, and the remaining 16 the bytes, and that. So likewise, if you go and write, I'm going to change this to probably all these 16 bytes to 0. Then I'm going to write this. You could have just filled everything with 0 fill, but I want to write only. So go to page that is at the end. So 976. So I want 16 bytes starting from address 976. If I hit W, so this is the APDU or vendor specific command for writing. So here again, this is structured as a TLV block. Now you just have to refer the documentation for what is the A2 tag means, followed by A1 tag, followed by A7 tag. And one thing is very obvious, whenever you write to a EEPROM, you must have the address of the EEPROM plus the length of the plus the data. So somewhere here, so if you think the 16 bytes, okay, starting from 0, if you think this is 16 bytes I want to write, if you look at that, if you go from in the reverse direction, these are the 16 bytes, this is the V, and the corresponding L, it's a 10, corresponding tag is 83. So this is the length of the data to be written. So before that, you're going to have again a kind of like a TLV, probably just try to see it's A7 followed by 16 bytes. If you look at here, is somewhere here must be the address. I think this is the address. 81 is the offset. The documentation refer this as offset, so is nothing but address. So 81 is the offset. This is the, take this tailway as an example. It's good to learn this tailway structure. So it's a 81 followed by length is 2 bytes and followed by this offset. If you convert 03 D0, you will get the address 976, and obviously this must be some kind of a set command, and this must be an EEPROM command. Okay, so you have to refer the documentation in a, once you know the structure, it's very easy to understand documentation. The response code is 9D, which is a positive response followed by 00. So if you're programming this command, so you look for, you can look for the first 2 bytes. If it's a 9D 00, it's success, or any other value, it's a failure. Okay, so finally, if I hit this write entire memory, so the software uses a different type of commands here. It's trying to use writing in bulk. Now I somehow noticed you cannot write 240 bytes here, just like you are able to read 240 bytes, but you cannot write 240 bytes. I'm not sure what the reason is. However, you can go up to 100 here, 100 or 102 I suppose maximum, but I have used only 64 byte because 64, so this goes very well with the 16 byte page size. So I'm writing 64 bytes at a time. So this is just it's the same EEPROM write command, but with the different length. Probably the length goes here. So if you see the 83 followed by 40, this is the 64 bytes, and you got 64 bytes here, and everything else, always, okay, my advice is, whenever you try to read this type of TLV structured command, go from the reverse. So look for some kind of 83, 81 series. These are the commands. Okay, so you're able to write 64 bytes. Obviously, writing in this chunk will be faster than writing a single byte or 16 bytes at a time. Okay, I think that's all you got in this video about EEPROM. So to summarize, what you learned in this video is how to read and write to the EEPROM of 5022 or 5422. So if you got a later version of the reader writer like 5427 CK models, you just have to check the documentation and make sure the EEPROM is present, and also you also have to make sure that the commands that are used here is also present in your reader writer. You have seen how to read in bulk, you have seen how to write in bulk, and also seen the structure of the read and write commands. Okay, thanks for watching.